Hello everyone, this is the demonstration phase of the example code counting loop control of the Servo 6. My goal were trying to show you what is the structure of the counting loop, and then what is the iteration effect on the parameter that you may be using in the loop, especially if you use a counter that is used in the counting loop. And we'll also do a presentation on a bit representation and how many bits is represented in ROBOTIS software and how much it is used, how many bits is actually used in the task parameters. You need to make sure to understand the difference. So let's go to it. In the example code, the Servo 6 is only involved. So initially the goal velocity is set at 150. So remember the maximum goal velocity is 1023. So 150 is pretty low. And the structure for loop for a counting loop, you can see it go from 15 to 27 here. There is a parameter. You can name it as you want. I happen to be naming it as count here. This means it can go 1, 2, 3. So it's gonna go 1, 2, and then 3. Inside of it, the first loop, the first statement inside the loop for, it is set up the goal velocity. So every time it loops through here, 1, 2, 3, or 4, it changes the goal velocity first before it tells to go to position 0, minus 90, and plus 90. Okay, so the first time it goes through, it takes goal velocity, which is 150 by default when it first starts on the loop for, multiplied by the count, which happened to be 1. So the first time it goes through this counting loop, the goal velocity is really 150. So next time around it goes in, it say, oh, take the current goal velocity, which happened to be 150. You multiply by the value of the count now, which happened to be 2. So therefore you get 300. So it going through the second set of moving 0, minus 90, and plus 90 at speed 300. So a little bit faster now. And then to finish the second loop, it goes in the third loop. At that time count equal to 3. So you take the current velocity, which happened to be what? 300, not 150 anymore. So watch out. Third time goes around, the current goal velocity was the last goal velocity set, which is 300. So 300 multiplied by 3, therefore equal 900. So it goes even faster. Okay. So when the code runs, you should see it moving around into from 0 to minus 90 to plus 90. Those 3 positions are done at fairly slow pace. That's 150. And the second one is faster, and the third one is the fastest. Okay, so let's have a look. I already downloaded the code, but right now I didn't turn the power on, so I'm going to turn the power on. So this is 150 first. Okay. Now at 300. So now at 900. Let's do it again so you can see. Slow, medium, and the fast speed. 150. 300 now. 900 now. Alright. So, we see the actual code right now is on. So let me try to change it to 200 here. And try to download this code. And to disconnect. Let's try to connect it back in again. Okay, it's happy this time. Now let's try to download it. Download 100%. Great. Okay, so this one here is starting at 200 now. So you notice I turn it off, turn it back on here. So we go at 200 now. Now we go at 400. So this is last time here, it should have gone very fast, but it didn't go. So let me turn it off, turn it back on again. 200. Second time faster, 400. Suppose real fast now, 1200, but it's very slow. Alright, so what's going on is because of this situation. When at 200, first time around 200, second time 400, second time around the actual number is 1200, but you saw that going slower. That is a problem because inside task, all the numbers use 16-bit, so it can handle 1200 okay. But the goal velocity itself is using only the first 10 bits. So 1200 in decimal translated into binary as this number here. So this is a 1 on what? This is 8, 10, 11 bit. But in the third iteration, it used only 10 bit for the goal velocity, so therefore it forgot that 1 there, so it only have this. And this number happened to be 176, so things suddenly slowed down for the third iteration.